Hello, good afternoon everyone. Myself Krishna Prasad S, Assistant Professor from Mechanical Engineering Department. So today I am continuing with module number 1, Introduction to Fluid Power System. Okay, so in the previous class my beloved colleague Professor Sachin is done with the what are the important points of the fluid power system, advantages, disadvantages and applications, along with the main components of the hydraulic system. So today I am continuing with the next topic. It is called the transmission of fluid at static and dynamic condition. Later the Pascals law, application of Pascals law and numericals on Pascals law. First of all, what is meant by the transmission of fluid at static state and dynamic state? So in any of the industry we all know that the transmission of power takes place from one place to the another place can be done in three ways. The one, it is called mechanical power transmission system, then electrical power transmission system and fluid power transmission system. In mechanical power transmission system, fluid power can be transmitted from one place to another with the help of the shaft, pulley as well as the gear. But in case of the electrical power transmission system, power can be transmitted from one place to another with the help of wire as well as from the transformer. But in case of the fluid power transmission system, power can be transmitted from one place to the another place with the help of the fluids like liquid or gas. So under that we are discussing about the transmission of power at fluid power system. So how transmission of power can be done in both static and a dynamic state. So before we are going to the static and a dynamic state, first we need to understand what is meant by the static and dynamic. So static, it is nothing but it is concerned with the fluid at rest or the forces are in equilibrium condition. Similar to the what is meant by the dynamic. So here forces resulting into the motion of the fluid. So that is called as dynamic condition. So then first one, it is called transmission of fluid at a static state. Here the transmission of fluid at a static state, it is nothing but hydrostatic. So how hydrostatic systems are going to work? So here in case of the hydrostatic system, here the motion of fluid from one place to the another place are considered without considering the forces and the movements that causes the motion. So one such example, it is called as hydrostatic condition, it is called positive displacement pump. So in case of the positive displacement pump, the fluid can be transferred from one place to the another place with the reciprocating motion of the piston, and such example it is called as the reciprocating pump. So what are the main parts of the reciprocating pump? The reciprocating pump, it is mainly consists of the cylinder, piston, crank, then suction valve, suction pipe, delivery valve, delivery pipe and the discharge tank and the sump. The main function of the reciprocating pump is to transfer the liquid from sump into the discharge tank. So how will be the working? So when crank rotates in the clockwise direction, then piston moves from TDC to BDC or outward movement of the piston. So a small suction is going to be created inside the cylinder. Due to the suction, this suction valve is open, hence the fluid is going to transfer from sump into the cylinder. So when further rotation of the crank, then the piston exerts force on the liquid and this force exerts the fluid flows into the discharge tank through delivery pipe and the delivery valve. So that here fluid going to transfer from one place to the another place with the help of force acting on the fluid. But very important condition in case of the reciprocating pump, it is called here the pressure forces remain same at all the points in the fluid, and also the flow it is not continuous. So that means the flow it is first takes place from sump into the cylinder, later cylinder into the discharge tank. Therefore here the fluid flow it is not continuous, instead it is called discontinuous flow. As well as there is also internal seal is required whenever the fluid flow from sump into the cylinder, discharge valve should be closed. Similarly, when the fluid flow from cylinder into the discharge tank, suction valve should be closed. So this is what happens in case of the hydrostatic condition. That means in case of the hydrostatic condition, pressure acts at any point of the fluid remains same in all the direction. So that is called hydrostatic condition. So next it is called transmission of fluid at dynamic condition. So in case of the transmission of fluid at dynamic condition, here the pressure forces are considered during the motion of fluid from sump into the discharge tank. So One such example of transmission of fluid at dynamic condition, it is called non-positive displacement pump. So the example of non-positive displacement pump, it is nothing but centrifugal pump. How centrifugal pumps are works? It's very simple. This centrifugal pump having an impeller, and this impeller, it is surrounding by casing, and then the outlet of the casing is connected to the delivery pipe, and this delivery pipe is connected to the discharge tank. Similarly, the inlet of the impeller, it is connected to the suction pipe, and the suction pipe is immersed into the sump. Very simple. When electrical motor is switched on, it starts rotating. Due to the rotation of the impeller, a suction is going to created inside the impeller. So due to the suction, so the water from the sump, it is enters into the center of the impeller. So once it is enters into the impeller, here due to the rotation of the impeller, centrifugal force is going to develop. Due to the centrifugal force, the velocity of the water is going to increases. So then kinetic energy of the water is then enters into the casing, but the casing area of the casing is gradually increases towards the pump outlet. So what happens when the area of the casing is increases, the pressure is also going to increases. Then highly pressurized air, it is enters into the discharge tank through the delivery pipe. But in case of the hydrodynamic condition, the best advantage, it is called air flow is continuous. Air flow is continuous from sump into the discharge tank without any positive internal seal takes place inside the components of the pump. And as well as one more such advantage, it is called air pressure is varies because the area of the casing is gradually increases towards the pump outlet. So this is the main difference between hydrostatic and hydrodynamic condition. So first difference, it is called air flow is discontinuous, but in case of the dynamic condition, flow is continuous. And here positive internal seal is required when the transmission of fluid from sump into the discharge tank, but here there is no positive internal seal is required when fluid flows from sump into the discharge tank. And here pressure forces are always remain same at all the points of the fluid, but here the pressure forces are varying from because of the varying area of the casing. So the next topic, it is called what is mean by Pascal's law. So Pascal's law, it is going to reveal how fluid power system is going to perform the useful work. So the definition of the Pascal's law, it is very important. So the pressure applied to the confined fluid. So first we need to understand the word confined. So confined, it is nothing but it is a restricted area or volume. When pressure applied to the confined fluid is transmitted and undiminished. So what is the meaning of the word undiminished? The undiminished means there is no reduction of force. So force, it will be equal whatever you apply. So that is called it as the undiminished condition. So pressure applied to the confined fluid is transmitted and undiminished through all the directions of the fluid. Okay, that means whenever force is applied, it is transmitted and it is undiminished through all the directions of the fluid, and this acts in the direction at contact surface area of the fluid. So this is called Pascal law. So I repeat, what is meant by the Pascal law? Here pressure applied to the confined fluid, that means restricted area or volume, is transmitted and undiminished through all the directions of the fluid and acts perpendicular to surface contact with the fluid. So this is called it as the Pascal's law. So then where Pascal's law we are going to use, or what is the application of Pascal's law? So Pascal's law general application, it is called hydraulic jack. So hydraulic jack generally we can see in the car service station. So also Pascal's law explains how glass bottle it could be break with the help of the small moment of force through the stopper. Okay, so for such example, consider a stopper of having an area of 1 inch square and it is fixed to the bottle of having the 20 square inch area. Okay, so this bottle, it is completely filled with water. Whenever a 10 pounds of force is applied through the stopper, then 10 psi pressure is going to develop. Then this 10 psi pressure is transmitted and is undiminished, then it is enters into the bottom of the bottle. But bottom of the bottle having an area of 20 square inch. Therefore, 10 psi into 20 area, then it will become 200 pounds of force is going to develop at the bottom of the liquid. This 200 pounds of force could enough to break the bottle. That means here the small force is used to break the big bottle with the help of the Pascal's law. So this is regarding to the Pascal's law. The next topic it is called the applications of Pascal's law. So already told what is meant by the Pascal's law. So pressure applied to the confined fluid is transmitted and undiminished through all the directions of the fluid and acts on the surface area contact with the fluid. That is called Pascal's law. So next we are application, it is called analysis of hydraulic jack. So the hydraulic jack we can see in the place where car service station. So in the car service station it mainly consists of two hydraulic cylinders. The one it is having the small diameter cylinder, other one it is called it as the large diameter cylinder. So small diameter cylinder having an area A1 and a large diameter cylinder having an area A2. So here small diameter cylinder having the piston P1 and large diameter cylinder having the piston P2. So this hydraulic jack it is used to analyze the working of Pascal's law. So very first important thing it is called when force F1 is applied to the small diameter piston. So this will move downwards with a displacement of S1. So when force F1 is applied to the piston 1, then the pressure P1 is going to develop. This pressure P1 it is transmitted and undiminished and travels down to the bottom of the piston. Once it is travelled to the bottom of the piston, this pressure is transferred to the large diameter cylinder. So that is having an area A2. So hence the pressure P2 is going to develop. This pressure P2 is exerts the pressure on the piston 2. Hence the force F2 is going to develop. But according to Pascal's law, that means pressure at all the points of the fluid is same in all the direction. So by Pascal's law, P1 is equal to P2. So P1 it is called the pressure acting on the first cylinder and P2 it is pressure acting on the large diameter cylinder. So P1 it is nothing but F1 by A1. Similarly P2 is equal to F2 by A2. Therefore can I write F1 by F2 is equal to A1 by A2. So this theory it is used to determine whether the force or area acts on the in case of the hydraulic jack. Similarly, whenever I need to calculate the ratio of the movement of the pistons like S1 and S2, we need to consider one assumption. It is called here oil is incompressible. So when the oil is incompressible, then the volume of the liquid displaced by the piston P1 is equal to volume of the liquid displaced by the piston 2. Therefore, then V1 is equal to V2. Then what is V1? So V1 it is nothing but volume of the cylinder 1, that is equal to A1 into S1. Similarly, what is V2? V2 is nothing but volume of the cylinder 2, then that will be equal to A2 into S2. So then I can write A1 by A2 is equal to S2 by S1. So from equation 1 and 2 I can write it as F1 by F2 is equal to A1 by A2 is equal to S2 by S1. So this is the derivation by the analysis of hydraulic jack with the help of the application of Pascal's law. So the next thing it is regarding to the numericals based on the application of Pascal's law. So in this numerical the datas are given. For the hydraulic jack the following datas are given below. That is called here the area of the first cylinder it is called 2 inch square and area of the second cylinder it is called 20 inch square. Similarly, so displacement obtained by the piston 1 it is called 1 inch and the applied force, it is called 100 pounds. So determine force developed and then displacement obtained at the cylinder 2 and energy input and energy output. So we know the equation F1 by F2 is equal to A1 by A2 is equal to S2 by S1. So first I need to determine what is F2. In order to determine F2, I will take F1 into A2 divided by A1. So F1 it is nothing but 100 pounds, A2 it is 20, then A1 it is 2. So then it will become 1000 pounds. Similarly, I need to calculate what is the displacement 2. So S2 is equal to A1 into S1 by A2. So here A1 is given, that is 2, S1 1 and A2 it is 20. So then by solving this we can get 1 inch. So by the application of Pascal's law and the analysis of hydraulic jack, now we are calculated what is force developed and the displacement of the piston happens in case of the cylinder 2. So next I need to find out what is the energy input. Energy input, it is nothing but F1 into A1 and energy output is equal to energy output is equal to energy input, that we are get, it is called 100 pounds inch and 100 pounds inch. So this is regarding to the numericals on the analysis of hydraulic jack with the help of the application of Pascal's law. Next topic, it is called the fluids used for hydraulic system. We are all know that in case of the fluid power system, so fluid is the one of the important phenomena. It is used to transfer the power from one place to the another place. So in this, what are the different types of fluid it is used to transfer the power from one place to the another place, it is very important. So some of the important fluids, it is easily available in nature, and to transmit the power from one place to another place, it needs to be discussed. So under that, very first one it is called water, second one it is called petroleum oil, third one it is called water glycol, and fourth one it is called synthetic oil. So we are all know that why the water should be used, because water it is easily available in nature, but the application of water in case of the fluid power system, it is limited. Why? Because water it is having the properties like corrosive in nature as well as it is tendency to rust. That's why water it is not applicable in case of the fluid power system for particularly in higher applications. And it is also another one disadvantage in case of the water, it is called, it is improper in lubrication. That means whenever hydraulic component system, when the fluid flow from one part to the another part, so because of the heating property, the water may get loses its viscosity. Because of that, the water we are not used in the higher applications. So the next one, it is called, because of the disadvantages in the water, we are going with the petroleum oil. The petroleum oil, it is more advantageous than the water because they can provide the good lubrication property as well as they can also prevent the rust. But the petroleum oil also having the disadvantages because the flammability, it is also one of the disadvantages, because at higher temperature the fluid may get burned, and it is also having the certain ignition temperature. Behind that temperature, petroleum oil cannot be used for the complete hydraulic system. And the third one, it is called water glycol. What is meant by the water glycol? So water glycol, it is called non-flammable fluid. So that means it contains 35 to 50% of water and 50% of glycol. So this will going to prevent the rust as well as provide the good lubrication property, and it is also provide, so this is also going to prevent the corrosion. So that's why water glycols are used. And the next one, it is called, what is meant by the synthetic oil? The synthetic oil, it is also called it as the non-flammable fluid, and the main advantages of the synthetic that at higher temperature it will not going to burn and it does not going to lose its viscosity. That's why the synthetic oils are used. These synthetic oils are used by the chemicals known as phosphate esters. And next, it is called it as, what are the important properties of the fluid? The first one, it is called viscosity. So what is meant by the viscosity? So viscosity means it is the ability of the fluid flow with its own resistance. So that means the viscosity should be at correct stage. That means if the viscosity is very low, then will the problem of improper lubrication. If the viscosity is very high, then the mechanical components will not move properly. So that's why the fluid should be provided the proper viscosity. Next, second one, it's called viscosity index. So viscosity index, that means the fluid should provide the correct viscosity during the complete operation. That means during the complete hydraulic components, the fluid will flow from one place to the another place. That means it does not going to lose its viscosity at any stage. That's why viscosity index should be at proper condition. Next one, it's called demulsifiability. That means the fluid should provide the proper lubrication, and it was also going to prevent the tendency of rust and also prevent the tendency to get foam. So next, fourth one, it is called the fluid to prevent oxidation. That means at the entire life it should not go into oxidize, and it should not go into corrosive in nature also. So these are some of the properties of the fluid if you are using in the hydraulic component.